Hi there, Kyle again, and this time we'll be reviewing how to graph a line given its standard form and graphing its intercepts. Since we'll be using them, let's define the x and y intercepts. The x-intercept is where the line intersects the x-axis and when y equals 0. The y-intercept, which you already learned about from graphing y equals mx plus b equations, is where the line intersects the y-axis and when x equals 0. When we said that b was the y-intercept, that's because our x-coordinate was 0, and substituting 0 for x would yield y equals b, meaning that there was a point at 0, b, which was that y-intercept. The standard form of the equation of a line is ax plus by equals c. A and b are the coefficients of x and y respectively, and c is a constant. X and y, of course, are the x and y variables. In order to graph the equation, you'll only need 2 points, and we'll be using the x and y intercepts for this. In order to find these intercepts, we'll substitute 0 for the x and y values. By substituting 0 for x, we can solve algebraically for the y-intercept. Substituting 0 for y, on the other hand, will help to solve for the x-intercept. Graph these 2 points, draw the line through them, and you've graphed the equation. Now pause and try these next 4 problems for yourself. All right, let's start with problem number 1. Our goal is to find the intercepts, so let's start with the x-intercept. We'll set y to 0, and we'll get 4x plus 0 equals 0, and x equals 0. This means that our x-intercept is at 0, 0. To solve for the y-intercept, we'll set x to 0 this time, and we'll see that y equals 0, meaning that the y-intercept is also 0, 0. Now the x and y intercepts are the same point, but we need 2 points to graph a line, so what should we do? Well, in these cases, you can transform the equation into slope-intercept form by doing a little bit of algebra. If we subtract 4x from both sides of the equation, you'll get an equivalent expression, y equals negative 4x. We can graph this equation just like any other equation in slope-intercept form, and if we draw a slope triangle, we'll get a point at 1, negative 4, and we can finally graph the line. When you have equations with non-zero a and b values, but your c or your constant is 0, you'll have to graph equations like this. Moving to problem number 2, let's try to find the intercepts again. By setting y to 0 and then dividing both sides of the equation by 10, we'll see that x equals negative 3 over 2, and that's our x-intercept. By going back and substituting 0 for x and then dividing by negative 3 to solve for y, we can find that our y-intercept is 5. If we graph both of these intercepts, we can draw the line connecting them, and we're done. We've graphed the equation. Let's repeat this process again and try number 3. Substituting 0 for y, we'll see that the x-intercept is negative 3, 0. And doing the same, substituting 0 for x, we'll see that the y-intercept is 0, negative 3. So go ahead and graph these points and finish off by graphing the line. Last but not least, let's try number 4. Just like when the slope or y-intercept were missing from an equation in slope-intercept form, so just like in problem number 1 here, the coefficient of y in this equation is just 0. So if we plug in 0 for y, we'll get that the x-intercept is 5. But interestingly, any value we plug in for y will give us an x-coordinate of 5. If we plot all of these points on a graph, we get a vertical line. Conversely, if we substitute 0 for x, there are no y values that could make the statement true, meaning that there is no y-intercept. Remember that the graph of an equation is simply the set of points that make the equation true, so this line is a collection of points with an x-coordinate of 5. I hope this review video has helped you with graphing equations in standard form by finding the x and y intercepts. Remember to try and have fun if you can, and take care of yourself. Always ask questions if you have any.